Sorry? I don't have a recycle bin. Christian. Be here. Alright, if you guys would find your test review number 32 in your binder, please. Olivia. Alright, so we today are going to continue to try to move closer to being ready for our second big assessment. It's going to fall next week on Wednesday, I believe. So we've got this class and one more class to try to connect some dots. So the three things we're going to look at together in class is I'm going to take your questions from your test review. So you had most of last class to work on that. And I'd ask you to try the rest for homework, so hopefully you have all your questions ready to go. And then number 33 is two of the pages you picked up this morning. The one that says Khan Academy Practice Test, Most Missed Questions. So last year I gave that out as an optional assignment. And these were the questions that students struggled at more than others. And there's a few good things worth talking about in there. So I figured if students last year struggled with those and they're in Unit 2 of Khan Academy, then there's a good chance there might be some things in there that you would benefit from. And then finally we'll round out with number 34, which is a circuit on chain rule. So I kind of like to do number 33 together as a group. And so my thought here is as people ask questions over 32, the ones that don't pertain to you, the ones that you're good with, you could work a question or two from the chain rule circuit. So that way you'll have less to do at the end. Okay, so from your test review, again, it's spaced out quite a bit, which is why it's so many pages, but we need to know the standard and alternate form of the definition of a derivative so we could work questions like 3, 4, 5. You certainly need to know the power rule, the product rule, the quotient rule. We need to consider chain rule every time we take a question, take a derivative. We need to know how speed and velocity are the same and different. We need to be able to read graphs like these to determine when something's going left, right, at rest, and something about the acceleration. How to write the equation of a tangent line, knowing when you would have a horizontal tangent line, having the trig derivatives memorized, knowing some of the notation for derivatives and second derivatives, and then finally just a little bit of practice that goes along with that. So let's look at this one page at a time so we're not jumping around too much. So the first page only had standard definition of derivative, alternate form of derivative, and power rule, and a couple practice questions. I think most of you guys asked the questions you needed to on this last class, but if you didn't, now is your chance. Anything from the front page of the test review you'd like to discuss?
I just don't understand how to do it. Like number 3 instead of 5.
Okay, you need to look back at your notes then. I can help you if it's something specific, but I can't reteach it from the start. So you got to have something to start with. Does somebody have something from the front page? Number 5? Okay. So when you look at number 5, does this look more like the standard definition or the alternate form? Alternate. So instead of trying to scan up at the top of your page and then back down here, you might write it out. And you very much need to memorize it, because if you don't memorize it, then you can't, you don't know what you're expecting to be where. So it looks like right here is supposed to be the function. So the function is supposed to be cosine x. And so that should throw off a couple choices. Which of our choices does not have cosine x as a...
A and C.
Right. A doesn't have that as a function, and C doesn't have that as a function. So just from that, you've already got it down to 50-50. The other thing you need is A. What is A in this problem? 0. And what does A represent? A is what you're trying, the value that you're trying to find the derivative at. So if A is 0, you're trying to find the derivative at 0, not at 1. So that's how you can narrow down to choice B. Okay, is that enough for that one? Okay. Anybody else that was going to ask this one? Okay, then moving on to page 2. If I'm moving on too quick, I'll give another chance at the end. Looks like page 2 had product rule. Obviously, you need to have that memorized, so you can do questions like 9 and 10. And the quotient rule, so you could do questions like 12 and 13. And I guess 14 and 15 are on there as well. So, any of the review on product rule, quotient rule, chain rule, or any of those practice questions that gave you more trouble than the others? Okay. Then, again, if I'm going too quickly, you're welcome to speak up once I give a chance on all the pages. Looks like the third page had number 16, which was another chain rule practice question. That one was a little bit harder. So if you didn't get to that one in class last time, I suspect you probably picked C, and the answer is not C. So make sure you're checking your answers there. Knowing the difference between speed and velocity, how they're almost the same thing, but what could be different. We did this question in our calculator earlier, but if you need me to remind you of that, we can. And then how to read a velocity graph to know when it's going left, right, at rest, and how you're supposed to use a velocity graph to know something about acceleration. And then information about writing the equation of a tangent line. So which of these things would you like a refresher on?
Could you go over the tangent line?
The tangent line down here?
Yes.
Okay, so a tangent line is like a visual like this. And a tangent line is always going to be a linear line. So it's much easier to do point slope Now on an FRQ, if you did slope intercept, that would also be acceptable, but I can promise you point slope is much easier. And there's 3 values you've got to plug in for point and slope. These are the 3 that you need to be replacing with numbers. X1 is usually given to you. We need to tell you where we want the tangent line made at. Sometimes we tell you the y value. Sometimes we just say it goes to the point 1, 3. So you plug 1 in for x1, 3 in for y1. But sometimes we only give you this one. So how do you normally find the y value if you only have the x value? Okay, plug it in to what? The function. Good. The function gets you points. Plug in the x value, solve for y, you know its y value. Just like when you're making a table. You're plugging in random x values, evaluating and getting y values. None of this is calculus. Number 22 is the only calculus step. The slope, m, comes from plugging in x1. I want to say this down here too. Plug x1. Now, if you plug it into the function, you know its value, the y value. If I want to know the slope, I should be plugging it into what? The derivative. So you need to know where all those pieces come from and know how to throw them together into an equation. This is something that will carry on throughout the year. Okay, is there a question about 21 through 24?
No.
Okay. Addison, that's enough?
Yes, thank
Okay,
you.
anybody else going to ask here? Okay, what you got? Sebastian?
Number
18? Okay, this one, you have velocity and you want acceleration at t equals 1.5. I probably should have put on here that I wanted you to use the calculator on this, but this is the exact same question we did on one of your notes. What's the relationship between velocity and acceleration?
Acceleration is the gradient of velocity.
Okay, so you should be able to, well, either take the derivative and then plug in 1.5. You should be able to take the derivative of that, but plugging in 1.5 is not going to work for you. So, assuming your calculator's in radian mode, all I'm wanting you to do there is remember that your calculator can take a derivative, alpha window, option 3, and what was the function? Or the velocity function?
T times sine squared.
Wait, say again.
T or x times sine squared.
Is it x squared
Yes.
or sine squared?
Or x, yeah.
Okay, and we really only need to know the derivative at, was it 1.5?
Yes.
So let your calculator do it. Because I'm using a trig function, sine, cosine, tangent, my calculator has to be in radian mode for that. So, but you need to know the derivative of velocity is how you're supposed to know something about acceleration. If that wasn't 1.5 and it was something easier to work with, you wouldn't need a calculator there. You could take the derivative with product rule, chain rule would be in that, and then you'd have to plug in the number. But based on this 1.5, that's not something you could have done by hand, so that's why it's a calculator. Yes?
Will we be allowed to have a calculator for the test?
Depends on what questions we put on there.
Okay.
Typically, we try to do some calculator, some no calculator.
Okay.
It's kind of hard at the beginning of the year, but on your AP test, half of your points come from calculator questions and half your points come from no calculator questions. So, but I will tell you that the calculator section, some questions are on the calculator section, not because you need a calculator to solve them, but because the calculator doesn't help you anyway. So,
Yeah.
yes, Grace.
Yeah, how do you get to the bottom?
How do you get to what? Alpha window, option 3. That?
Yeah.
Yep. And this, I've been saying this one quite a bit at the beginning of the year, so y'all know it exists. Again, I don't bug you about it all year long. You'll start to tune me out anyway, but it'll pop up 3 months from now. There's going to be one question on a test that you can't take the derivative by hand, or it would be too time consuming, and you'll have a calculator, and half of you will remember, hey, I can just type this in, and half of you won't, and you'll think that it's much harder than it really is. So, okay. Anything else from this page that's ready? Okay, on the next page, horizontal tangent line, knowing what that is to know when it would occur. The trig derivatives you need to memorize. Knowing the notation for first derivative or second derivative. 2 ways to ask for first derivative, 2 ways to ask for a second derivative. For second derivative just means you take the derivative twice, or you take the derivative of the derivative. And then question 38 and 39 are the 2 practice ones there. Yeah.
You do 26.
26, sure. Okay, so this one says find the equation of a tangent line. So just like we just talked about on the bottom of the other page, I would start off with this. I know it's going to be linear, and the quickest way for me to write linear is point slope. At the point, pi over 4, 1. So sometimes I have to plug in pi over 4 into the function and solve for y, but they just gave it to me. So plug in the x value in for x1, the y value in for y1. But to know the slope, you have to understand that slope and derivative are basically the same thing. I want to know the derivative when x is pi over 4. So I want to know this. So what is the derivative of tangent?
Secant squared.
Okay. Secant's the reciprocal of cosine. So what's the cosine at pi over 4?
Square root of 2 over 2.
Okay, so then the secant of pi over 4 would be the reciprocal of that. But I want it squared anyway. So to square a fraction, you multiply it by itself. Do you see how that's going to simplify to 2? So at that x value, the slope is 2. That was the last key to plug in. As an FRQ, I would absolutely be done. But as a multiple choice, I don't know. They got really, I have no idea why they wrote the answers this way in this question. There's really no rhyme or reason here, but they wanted you to mix this up a little bit. So I don't know. We could distribute the 2. None of the answers have fractions in them, so let's maybe multiply everything by 2 so that mine doesn't have fractions either. And then it's starting to kind of look like that. I don't know. Maybe if we subtract this over, we would get a 4x minus a 2y. And then if I added this over, I would get a pi minus 2, and that looks like choice C. So there's not any real particular reason why they arranged it that way, but once I got to here, I just had to try to simplify it until it looked like one of their choices. But
Sorry.
what's absolutely critical is knowing point slope form, knowing where the values come from, and then if you need to distribute and move stuff over and combine like terms to figure out which answer is equivalent, then you got to do that. But yes.
If there's something like this on the test, will it be like what you got when you first solved it, or will it be all mixed up like this one?
It could be either.
Okay.
Most of our, so again, we've only had the one like 20-point quiz so far, but most of our tests we try to use is all or mostly AP level questions. So this was a real AP level question. So that little bit, this little bit here makes the question a little bit harder, but we also curve them pretty good to balance that out. So
Okay.
yes, Grace.
Are there gonna be like, or are there already online resources to go over this stuff? Are there?
I mean, you can practice this skill at this link.
But like specifically for the, okay.
There's also, if you really want the progress checks in AP Classroom, I can unlock those for y'all. Usually this early in the years, those aren't the best. Huh? 37?
I think I just find that
But I guess if what you're asking is like, is there some worksheet out there where this exact skill and all of this same type of simplifying happens every time? No, because you may never need to simplify it like this again. So, unfortunately, the AP test is not like your other math classes. Other math classes, you learn these 10 skills, you practice the 10 skills, and then on the test you show that you can do the 10 skills. But on your AP test, so why we have to do this to y'all so that you get accustomed to it, but we do curve them to try to balance that out, is this is a skill we need you to have. Understanding where slope is a skill that you need to have. Figuring out the point is really an old thing. But you may never see another question where they take point slope and distribute and move some stuff to the left and some stuff to the right. You may never see that again. So you just have to learn to think on your feet there. All right. Sorry, Olivia, what number did you say? I forgot. 36? 37? Okay. Well, 36 and 37, these are the two ways to say if it's got one prime mark, it's talking about the first derivative, or dy dx is also the first derivative. Both of these are asking for the same thing. 2 prime marks means it's asking for the second derivative of the function. And then with this type of notation, I don't remember the mathematician's name that goes with this, but the d squared y over dx squared is its way of asking for the second derivative. So if they give you the function and they ask for this, they're wanting you to take the derivative once and then take the derivative of that to get the second derivative. If they give you the derivative, they want you to take the derivative again to get the second derivative. So just notation. And not that you care, and I don't remember the names anyway, but this type of notation was made up by one mathematician, and then this notation was made up by a different mathematician. You'll see that the prime marks are probably a little bit easier to work with, which is why I like to use those a lot, but you're going to see throughout the year that sometimes it's nice to think of them written like that, so we got to be used to seeing them both ways. Yes, what you got? 33? Sure. So this one, you have to memorize the derivative of secant something is what?
Negative cosecant.
Okay, so negative cosecant something, cotangent something. That's not the correct derivative because I didn't remember to do the thing that I said you have to always think about. What else do I need for my derivative here? Right, the chain rule, the derivative of the inside. So that would be 1/2. So this is what the answer is supposed to be. And C is pretty close, but he's positive. A is pretty close, but it forgot chain rule. B just wasn't the right derivative. D is just not the right derivative. This was none of these. Yep. The most important part, or what I'm most worried about for you at this point, is this 1/2. Did you remember to take the chain rule? Because if there's sometimes you're forgetting it, that is a bad sign. If you forget it on the test, there's probably 5 questions out the window that you won't be able to do. Or you'll be able to do them, but your answer's not, you're not going to get the right answer. Okay, let's move on to the next page, and again, we can come back if as needed. So the next page looks like it has natural log derivatives, some of the properties, and then a couple of the questions just kind of mixed up. So you didn't know exactly what topic it was, but you should be able to do those if you're okay with those on the other page. So up to 52. Anything on this page? Yeah. 51, sure. Okay, and I do remember 51. This is one we used to put on our test, and I think it is a real released question. So they give us the function, they want the derivative. Based on how this is written, which rule am I going to need? Okay, you're going to need quotient rule. So quotient rule says take the derivative of the numerator. What do you think the derivative of the numerator is?
E to the 2x. Oh, then just times 2x.
Times, not 2x. Chain rule, what's the derivative of 2x? Times 2 times the denominator left alone minus, and then leave the numerator alone, take the derivative of the denominator, which would be 2. And the most forgotten thing is that it's all over the denominator squared. Are you okay with where all those parts came from? I'm most worried about this.
That's the part I forgot.
That's the chain rule. That's why no matter how many times I say you guys need to consider it every single time you take a derivative, the one time you forget, it will make you feel confused because your answer is either not going to be there or you're going to end up missing it. Okay, but to finish this off, I don't know. Both terms in the numerator have e to the 2x, and they both have a 2, so we could factor that GCF out, I guess. Bless you. The denominator, 2x squared, would be like 4x squared. Just trying to look at some of the choices. I don't know. I'm going to guess that they reduced 2 over 4. Oh, I have a mistake here too. I should be a little more careful. There should have been a 2 in here. And
that would still be a 2 down there, right? Yeah.
oh yeah, 2 over 4 reduces to 1 over 2. And that is choice E. So, make a big note here. This 2, very easy to overlook. The derivative of e to the x is e to the x, but the derivative of e to the 2x is going to be e to the 2x times the derivative of 2x. Okay, that's enough. Sam, that's enough? Yeah, okay. Anybody else that was going to ask about 51 have something more specific in it? Okay, then moving along here, what else on this page, if anything?
It might be like a simple mistake I'm making,
Okay.
but on 50,
Mm-hmm.
why is it like negative? You have negative sine x times 1 minus cosine x,
Okay.
and then on the key you have minus sine x.
Oh, I have no idea. I don't remember the key.
Why?
So, I don't know. I don't know what part of the question you're talking about to be able to answer that specifically. So, what rule did you use to take this derivative?
Quotient.
Okay. Something divided by something, you can use quotient. So, derivative of the top would be negative sine x times the bottom left alone minus, product rule has a plus in the middle, quotient rule has a minus in the middle. The derivative of the denominator would be
Oh,
sine x negative sine x, so that becomes positive sine x, so the minus stays the same, times, because there's like 3 negatives there. You've got this minus that was already there, you've got this minus, and when you take the derivative of this, it creates another minus or another negative.
that answers my question.
Okay. Okay, then let's move on to the next page, and then I can give you one more chance from anything else on the rest of the pages. 53 through 56. These were just some scrambled questions, so not different skills, but just you weren't told exactly what you needed to be focused on. So any of those you'd like to talk about? Yes. Let's go.
I don't know the first step that you should take for 56. Like, where would you start?
Well, you can always just start with the normal derivative stuff. And I'm not going to go this route, but you guys can see that this is why you really, really, really want to know your algebra, exponent rules, fraction rules, all that kind of stuff. Because even though I could do this one without some of that stuff, I want you to see how bad it's going to be. The derivative of natural log of something is the 1 over the something. But now I have to take the derivative of the inside, which is going to be his own quotient rule because of chain rule. So derivative of the top times the bottom left alone minus the top left alone times the derivative of the bottom. And so I've got a complex fraction times all of this mess. You can see how you don't want to have to simplify that if you don't want to. So the smarter play is, if you remember, and again, you may not need this for this test at all, but I'm pretty sure it comes up once at least this year. Expanding and condensing logarithms. Do you remember if you have log of something divided by something? Do you remember how to split that up?
Log of the top first minus log of the bottom.
Good. Division expands as subtraction. And so if you consider doing that and then doing the derivative, this is one you're supposed to have memorized. This is really the same thing. It does have chain rule, but it's a much easier chain rule. So I could do that much faster than I could even write that out, and this would need another 10 minutes of simplifying. So do you have to know how to expand logarithms to do that question? No, but for your sanity, it is certainly nice. Okay, check to make sure there's nothing from the first, second, third, fourth page, any page that I moved on too quickly from. Give you another chance.
Did you use Boogie Nights?
Are you sure? This is the hardest one, I think, on the whole thing. The messiest question for sure. What makes this question messy is that it's not just wanting the derivative, it wants the second derivative. So first off, you have to take the first derivative. So bring the power down, lower the power by 1, and don't forget chain rule. So that is 18x times 3x squared minus 1 squared. Do you see how that's one of your option choices? Okay, but why is that not the answer? Right, that's only the first derivative, and it's asking for second, so it's making sure you're paying attention. Now, the second derivative is the derivative of the first derivative. And unfortunately here, this gets a little bit messy. That's why I said this one's the hardest. So I've got 18 times, and then I'm going to do product rule here. You need to put your name on your board, please. Okay. So derivative of the first would be 1 times the second thing left alone. I pulled the 18 out front. The whole thing's just going to be 18 times bigger, so I don't have to mess with it. Then the derivative of, or leave the first alone, times the derivative of the second, which would be bring the power down, lower the power by 1, and I'm taking the derivative of this, so I've got to do chain rule, derivative of the inside. Okay, and I believe that would be my correct second derivative. But I gotta try to simplify this to match up the answer. So I've got this 18 that's already out front. It's already been factored out. What does this term and this term have in common?
They both have a 3x squared minus 1 in them.
Okay, so we can factor out that GCF. So this stuff distributed to my first term, because I'm undistributing here. What's left behind here would be a 3x squared minus 1. I needed one more of those. And then when I distribute this to this, I've got 2 times 12, or 2 times 6 would be 12. X times x would be x squared. And the 3x squared minus 1 got factored out. And so in the end, I had the 18 GCF that I just pulled out pretty much from the beginning of the second derivative. I've got the 3x squared minus 1 GCF that I pulled out in the last step. And then after I had pulled that stuff out, inside of what was left over, there's a couple terms that combine. 3x squared plus 12x squared makes 15x squared, and a minus 1. So all of that to get A.
Would they ask you one like that big on exam? Like where you have to expand it out?
This is a, I'm pretty sure this is a release question. So yes, they have asked that. Now, I would say that most questions aren't this long because this would be a non-calculator question, and on average they give you 2 minutes. So some calculus questions, if you know what you're doing, 10 or 20 seconds, but on average 2 minutes. This is a hard one to do in 2 minutes, so they're not going to give you 30 questions this long, but they certainly can give you a few that are this long. And I know I said this a lot in the first unit, but this still applies. Some stuff, like here at the end of this question, how to simplify this, seeing that there was a greatest common factor to factor out, that's not obvious for most people, and that's okay. You don't have to do that instantly. But in order to keep yourself from making this a 20-minute question, the thing, you have to know the basics well. You have to know that you need second derivative. The first derivative wasn't too bad. You need to be thinking of chain rule each time, because the second you forget it once, your answer is never going to look anything like the rest of them. If you're scrunching your work in too small, or you're writing too sloppy, or you're working in pen, and you're crossing off half of your work and then trying to figure out where you're supposed to be picking up, you're making the question harder than it has to be. So know the basics well, so that when you see hard questions like this, you can at least spend the bulk of your time trying to figure out how to simplify it. Not remembering chain rule, not remembering product rule, all that kind of stuff. Okay, anybody else from any page? Okay, then let's move over. So obviously I will take that up for grade, but not today. Let's look at this one. So again, I did not assign this to you guys. I assigned it as optional to last year. But again, if they had problems with these, then you guys probably could too. And a few of these things, I guess I'm showing you a little bit early, but it all is interconnected. So what I'd like to do on these questions is be more of just kind of filling the gap here. I know like question 1, I'm probably going to have to tell you what to do, but some of the others I would like some feedback on so I can see how it's going. Okay, question 1, and I do apologize. I know some of this didn't print off great. I reworked it yesterday. All these Khan Academy questions don't print the best, so I apologize. I usually try to darken it, but it just didn't do much this time. Okay, this wants to know if this guy is continuous and differentiable at x equals 2. Stops being this at 2, starts being this at 2. How did we figure out if it was continuous in the last unit? Okay, so we'd like to know this y value at 2, so that would be -4 plus 6. And we'd like to know this y value at 2, that would be 12 minus 10. So at x equals 2, this is at 2, and at x equals 2, this is at 2. So, can we all agree that it's going to be continuous? Okay, the differentiable is the part I'm worried about, because I've said this, but I haven't said this with a piecewise function. It's the same thing, but again, applying it to a piecewise just kind of feels different. To be differentiable means you can take the derivative. Well, when can you not take the derivative? If I had some kind of line, how do I know if I can take the derivative at all those places?
If it's continuous.
Okay, it does have to be continuous, but just because it's continuous doesn't mean it's differentiable. What's another word for a derivative? Slope. So what if the slope doesn't exist? Like here, right there, you can't take the derivative at that point. It's not continuous. It doesn't have a slope at that point. What's another way that a graph doesn't have a slope, doesn't have a derivative? A vertical line, very good. So like if for some reason for a second it was vertical, you can't take the derivative there. Undefined slope means undefined derivative. And then there's one more visual that you can't take the derivative at. And that's the one that we need for this.
Limit from the left and limit from the right, approach the same value.
That helps you with continuous. That's what we got by plugging in 2 into this and 2 into this. But you're close. Visually, you can't take the derivative at a cusp, at this sharp point. Y'all remember talking about that? You have to know that you can't take the derivative at a cusp. The reason why is the slope can't go from being this to this at an instant. It's got to be over time. Even if it's quickly, it can't be at an instant. So how we apply this to this question is I need to know the slope before 2. How am I supposed to know the slope of this at 2? One more time. Derivative. At 2 would be -1. So this guy has a slope of -1 at x equals 2. Derivative of this guy at x equals 2 has a slope of 12. So if your slope was -1 and then at an instant your slope is 12, do you see how that would be a cusp? It's going to be a sharp point. So is it differentiable? No. Those would have to be equal slopes. The main, and I'll even fix my picture to kind of match this. At x equals 2, it did have a slope of -1 right before it, but then instantly it had a slope of +12. Comparing those slopes, comparing those derivatives at x equals 2, I can see that I got a cusp. Okay, there's another one like that on here, so that one should go a little bit better. Okay, without me telling you, oh, I'm sorry, there's question 2 here. What's the average rate of change of this function from 2 to 4? So this is not one we talk about much because what's another word for what's another math term for average rate of change? Okay. So if we know where the function starts at, or I'm sorry, if we know where it ends at 4, it has a y value of 2 to the 5th, 2, 4, 8, 16, 32. Subtract how much of a y value it had to start at, which is h of 2. That would be 8. So it looks like from 2 to 4, it went up from 8 to 32. So that's a rise of 24. Does that mean the average is 24? Okay, why is that not the average? Slope is rise over run. It went up 24 over 2 units, so on average it went up 12 units. That's really just slope formula. Average rate of change is slope. Slope formula, that's all you can do there. If it was instantaneous rate of change, we would have to do derivative and plug in 2. I think there's one more like that later. All right, question 3 wants us to compare these two. Is the derivative at 1 or the derivative at 8? Which one of these is bigger? What does derivative mean? One more. Okay, so look at the slope at 1, look at the slope at 8. Which one of those has a bigger slope? 8 is closer to 0, isn't it? This is a steeper slope, but it's negative. Something close to 0 is bigger than something that's super negative. The derivative at 8 is bigger than the derivative at 1. Is that okay? Elise, are you convinced?
No,
Okay.
I'm confused.
Okay, this slope is almost 0, right?
Uh-huh,
It's slightly negative,
okay.
but it's close to 0. This guy is super negative.
Okay.
So this has to be a bigger number.
Okay, I get it.
That's all. Okay, number 4. What's the value of the derivative of this at 1? How would we do that? What's the derivative of this?
-4x -.
Okay. What's the somebody else? What's the derivative of that?
Negative 6 over x to 6, or x to that right side.
Okay. And then if we want to know what x equals 1, what do we do with the 1?
Plug it in.
Okay, so you end up with -4 plus 6. So 2 is the answer to question 4. You guys okay with why this derivative came from that, this derivative came from that, plugging in 1 where the numbers came from? Okay. Okay, number 5, using this table, and again yours didn't print off the best, what is the best estimate for the derivative at -1? So again, this is not different skills than we've talked about, but you guys just don't apply these same skills to tables and piecewise functions very successfully. So derivative means slope. So the best that I could do to estimate is to take maybe these 2 points and think about it goes down. How much is it going down from -1 to 1? Okay, over how much time? Okay, then we can estimate that the average must be -4. Again, we don't really know that's what's happening, but feel free to squeeze this in. If you think the slope is -4, then to go from here to here, this guy would be at about 49. And if it keeps going at that rate, at 1 it would be 45. It's going down about 4 each unit. Okay, we good with that? Okay. Here's one you guys asked about from the test review. Write an equation of a tangent line. So start off with this. At x equals 1. So we're giving you x1. You still need to figure out what y1 is and what m has to be before you get that answer. How do we find y1? Very good. Plug x into the function. If you want points, you use the function. And that should be 4. But if you want slope, you're not going to use the function anymore. You're going to use the derivative. So we got to take the derivative of this. And I really only care about what's the derivative at 1. So 6 minus 2 plus 3 will be 7. At the point 1, 4, it has a slope of 7. Only this part is the calculus, but this part, finding the point, you need to keep up with what the function's good for and what the first derivative's good for. It's also important because in about a month we'll be using the second derivative for stuff, and it has its own purpose. So it's really important to know function's good for points, derivative's good for slope, and then later on you'll know second derivative's good for something else. Okay with that one? I guess while this is fresh in my head, there is kind of an interesting math fact that you guys may have heard of in science, maybe not yet, but usually there's lots of good jokes about it. In physics, do you guys use, I know you sometimes talk about the first derivative, is that right? It avoids it, so you don't have to talk about that?
Non-physics too.
Okay. Well, first derivative we've used a lot. Second derivative is something else. The third derivative has a name, like a scientific name. The name of a third derivative is the jerk. So sometimes, like online and stuff, you'll see people with like math shirts, and it makes a joke about like, don't be a third derivative, because it's a jerk. So we don't really do any applications with third derivative, but just so you know, that's the thing. Okay, again, I didn't pick out these questions, I just picked out the most missed ones. What rule would we need to get the derivative in question 7? Christian, what rule would we need?
Quotient, right? No. Product, something?
1 over x is being what to sine x?
It's in my notes. I know what it is. I know how to work it. It's an inner outer thing, right?
No, it's not a chain rule.
Oh.
This is 1 over x times sine x. What's another word for times?
Product.
Product. Product.
Product something.
I didn't hear that.
Oh.
Well, I gave you 30 seconds. Okay, so we could take the derivative of this times this left alone plus the derivative of this times this left alone. And then if we need to simplify it, we need to simplify it. But product rule. Good with those parts? Okay, so this was something times something, so product rule. Number 8 instead is going to have to be quotient rule. You've got something divided by something. So derivative of the top times the bottom left alone minus the top left alone times the derivative of the bottom. And someday you're going to do this on a FRQ, and you're going to miss a couple of the easier of the 9 points on the FRQ because you didn't remember to put it over the denominator squared. It's multiple choice. We may need to simplify it, but good with that? Again, I'm trying not to waste your time here, but if you're not getting what you need out of that question, then okay. Okay, 9 is this stuff. All of this is 9. Some function g, they give us a couple values. What's the equation of the tangent line at g at x equals -1? So, equation of a tangent line. It's come up a lot today. Start off with point slope. The x value is given to you. You need to be told where we want the equation to be. Bless you. Sometimes to find the y value, you have to plug in the x value into the function. But in this question, they give it to us right there. G at -1 is 3. And then sometimes to find the slope, you have to plug the x value into the derivative. But it was given to us right here. The derivative of g at -1 is -2. So it was really just plugging in the pieces. I feel like that's easier, but okay, Ben, you already had that one done? Make sure you're staying with this. There'll be some time for chain rule later. Okay, everybody's okay with this now? Okay. Function f is graph. The graph has a vertical tangent at x equals 3. Find all the x values for f is not differentiable. So where could I not take the derivative here? Okay, 3, because it's undefined. If the slope's undefined, then there's no derivative. And where else? -3. There's no slope there. It's not here and here. It's got to be one thing. So there's two places you couldn't take the derivative at. It does not exist at 3 and -3. -3 because it's not continuous. 3 because it's undefined. Okay, 11 is like question 1. So I know this one felt a little bit different, but I want you to think about it for a second and actually try this one first, because I realized we hadn't practiced this before. But see if you got what you really needed from question 1. Okay, so basically what you should be testing is to make sure there's not a cusp at x equals 0. So you need to know the slope right before x equals 0, which you're going to get from the derivative. At 0 it would be 5. You need to know the slope right after 0, which you also have to get from the derivative, which is -3. And if at an instant your slope is going from +5 to -3, do you see how you have a cusp at that point? Which means it is not differentiable. can't take the derivative at a cusp. So you have to compare the slopes from the left and from the right. Compare the derivatives from the left and from the right. Okay, number 12, what's the average rate of change? So we did one like this on the other page. Average rate of change, just a fancy way to say slope. So let's figure out the ending value, subtract away the starting value so we know how much rise there was. And then if we end at 3 and start at 1, we can see that there's going to be a run of 2. So plug in 3, you get 2 over 6. Plug in 1, you get 2 over 4. And I don't know, depends on the question. If it's a free response, you can quit right there. You don't have to do any arithmetic in a free response. Multiple choice, you probably need to get a common denominator, subtract those 2 fractions up top, and then divide it in half. But average rate of change is this slope. Okay, 13. I don't know why this one was much of a missed question, but if I rewrite it like this, Christian, how are you going to take this derivative?
You gotta multiply it.
Be more specific.
You gotta take it down thing.
Okay, take it down.
And then subtract 1, so it's negative 2x, so it's negative 3.
Okay.
Then you plug in 5.
Okay, you want it at 5.
Super smart over here. Don't quote me on that.
Okay, what's 5 to the third?
125.
Too slow. 125.
I
You almost had that one.
was gonna say 25.
That's 5 squared.
Yeah. And then I have to do it one more time. I guess that's super genius next to Einstein right here.
Good. So 14, which one of these slopes is bigger? Or not slopes, sorry, derivative. The derivative at 1 or the derivative at 6?
Oh, the second one.
This has a bigger derivative than this?
I was joking. I was saying you were listening about the first one.
Okay, we don't joke about math. Which one of these is a bigger slope?
Exactly. What you put on your board, a joke. Yeah. Don't joke with it. Yeah, it's a greater than or less than. Or greater than. Well, that little sign that goes like this. Alligator. Crap. What did my teacher teach me? Greater than, yeah.
Opening which way?
This way.
That way?
Yeah.
Yes. Bigger slope, so bigger derivative. Easy question if you know what you're looking for. Okay, 15. I would like to estimate the derivative at 16. If derivative means slope, notice they don't tell me what's happening at 16. And even if they did, that doesn't help you with slope. Knowing the value at 16 doesn't tell you anything about the rate of change at 16. So what would be the next best thing?
Find the slope in between 15 and 17.
Perfect. So you could take your ending value minus your starting value to see that the rise is down 5. You can see it's going down 5, but not in 1 unit over 2 units. So it's going down about 2.5 each time. I guess you could also see if that makes sense. If I plug in 16 here, if I went down 2.5, this would be negative 65.5. And then if I go down 2.5 again to get to 17, that would give me negative 68. So we don't really know that that's the real derivative, the real slope, but with the given information, that's how you go about it. Estimate with that. Okay, 16, I don't know what this goes to. I think there was supposed to be a question with that, but probably take the derivative, but that's okay. It doesn't say what the question is, so we'll scratch out 16. And then 17, last one. This one you guys have been pretty slow on earlier today. These should be pretty quick answers if you know what you're looking for. what x values is this not differentiable at? Okay, it's certainly not differentiable at 5 because it doesn't exist. If there's no slope there, then there's no derivative there. And what else? y1. Right. And you really shouldn't assume that. You need this in the directions here. Vertical lines have an undefined slope. If the slope's undefined, then the derivative is also undefined, not there. Can't take the derivative at 1 or 5. Okay, so again, some of that stuff is not super relevant right now, but I think all of this kind of helps you see some of the same stuff in different light, so I think that is still helpful and worth our time. All right, we got a little over, or just under about 30 minutes for the circuit. But that's okay, because I meant for some of this to be homework. So go ahead. If you haven't started on this yet, please go ahead and start.
What number is this? 34?
Grace, to your left.
I know, that's why I answered my
Okay.
question.
Anybody want a stapler for 33?
That's my stapler.
Oh, yeah. This is his, by the way. Don't steal it. Well, you shouldn't steal it.
Still, you sound like you're trying to give it away.
No.
Okay, so from the last few years, I can tell you guys the thing that's going to not necessarily make or break your next test score, but what could make your next test score significantly lower than you want it to be is if you don't think of chain rule. So I know we've been doing chain rule, but we've got to get a little bit better at it still. And I'll wait and see which ones give y'all issues. You're in number 12? That's fine, I mean, I'm not complaining.
Can I do this? Like, does this work?
I hope you can.
I hope I can do it. Changing that to that.
Yeah, same thing.
Okay.
Yeah.
I'm like crazy. Is 2x like 1 just like x? Just making sure.
So I'm pretty sure it matches to here. Because like my answer would be 5 over, and my answer, I have 5 over x, would be 5 over x versus 7. But if we have the x here, we're not something.
Might not be the right answer then.
No? Is that the right
Do you think that's 3? Okay, I agree with you, this is going to be 3.
Just to get the comment.
Well, if you chain rule, did you do chain rule? Oh, no, you didn't. Right here. When you took the derivative.
Yeah, before you moved here.
What
So you can buy
number?
back them.
The number
Yeah.
2, multiply.
I'm not following your word. I don't know where this 2 is coming from.
Ours is like this.
When I multiply all of that by 2x.
You bring the power down,
Or should I?
Yeah.
so the 2 would be in the denominator.
This to negative 1/2.
Numbers.
If you bring 1/2 down,
Oh.
Because it's 1/2. That's a 5.
shrinks at 5 over 2. Oh, this is 2.5. I got you. Okay, 2.5.
And it would
I would write this, I wouldn't write that as a decimal. Change it to 5 over 2.
Okay.
Okay. And then times What's this? Why are you multiplying by this?
Isn't that the?
I already wrote somewhere
The
and.
derivative of x squared plus 7?
Yeah.
Whatever.
Yes.
That's way more complicated than
No,
that. Just the inside part.
then it came
The derivative of x squared plus 7 is 2x.
Oh, you don't do the square root?
I love.
You already did the square root. Chain rule is just the inside part of it now.
I can't. I'm not getting this right.
Okay, what are you trying?
Bring the 1/2 down, and then you just get x. And then it goes to negative 1/2, so you put it at the bottom.
It sounds like you're not using product rule there.
Wait,
Okay.
am I supposed to do that though?
It's x times the square root of some stuff.
I thought you were supposed to just do chain rule.
Chain rule is not a different type of differentiation, it's an extra step. Chain rule comes after power rule, after product rule, after quotient rule. So I would pull this 2 out, and just leave it out front of your answer the whole time. This is x times something, so use product rule. But when you take the derivative of this in the product rule, you're going to need chain rule because of that inside part.
So I know that 3/2 exponent is basically just the square root of something to the outside. So is this like a double derivative? So if you're like you got a derivative within a derivative,
It's going to be chain rule. Is that
or
what you mean?
I mean double chain. So you have to find the chain. Then you have to use chain rule for this, and then you use it.
You're going to bring the power down, lower the power by 1, and then chain rule will be derivative of the inside.
Oh, okay. I see.
You stuck on anything yet?
Is this the right way to write this?
Let's see. Okay, so the way they have this written, this would be the derivative of h at g times the derivative of g. Is that how you wrote it?
Didn't know. Would that whole thing be square root or just be square x times that?
I don't see where you're taking the derivative of h. You've got h of g. This is chain rule. You got a function plugged into another function. So, chain rule written this way, the way we did your notes, is the derivative of the outside with the inside plugged in times the derivative of the inside. And you want to know what -1. So you need to figure out what number you get from plugging -1 to g, plug that into the derivative of h, times what happens when you plug in -1 into g. So you got to find like 3 different numbers in there.
So I need to think about, not only do I have to do the inside, but the outside.
Did you want me to look at the one that you were worried about earlier?
Yeah, wait, no, wait.
On the test review?
Oh, no, I figured it out.
Oh, okay.
But also, can you work this out? Like, I can't, listen to like words and understand.
You can't listen to words?
I can't like listen to you tell me and understand. I need to like see it.
Okay. I would leave this 2 alone. I would just pull the 2 out so I don't have to worry about it.
Okay.
Because this is going to make it 2 times bigger anyway. This is product rule. So the derivative of x is
1.
times the second part left alone,
Okay.
plus now x left alone times the derivative of this.
Yeah.
So think of this to the 1/2. So you're going to bring the power down,
Yeah.
lower the power by 1.
Okay.
I'm just moving it to the denominator, make it positive. And then because of chain rule, you need to multiply by the derivative of the inside,
See,
which would
that's
be
where I get confused.
the derivative of x squared plus 7.
No, I'm not like confused, I just forget to do that.
I know, that's, lots of you guys will forget to do that, which
I
is why
know,
I'm making you do this chain rule practice, so that hopefully you're less likely to forget that.
That's bad.
I just left this 2 alone. I just pulled it out so I didn't have to leave it in my work. You can either pull it out at the beginning, or you can call this 2x and you would have it built into this. It's the same thing. It's like if I asked you what's the derivative of 2x, you could bring the power down, lower the power by 1 and get 2. Or you could say it's 2 times the derivative of x. Either way, you get the same thing. I'm just pulling the 2 and leaving it out front, so it's a little bit less messy.
You're close. Okay, why didn't you write down for them? Oh.
I think I just do some extra work, but I think it's gonna end up in this bottom. I'm gonna have to do some work to get there.
Okay, so you didn't pull the 2 out front like I did. So when you took the derivative of 2x, you got 2. Over here, you took the derivative of this. That's where this came from, right? But it should still be times 2x. Okay, then you forgot chain rule. The derivative of the inside is also 2x. The derivative of x squared plus 7 is 2x too. So that's where it works. You either forgot that piece or you forgot chain rule. They end up being the same thing in that question. Did you have anything to help with here?
I don't think so.
Wait, can I see yours real quick?
That's not even 16.
If you take the derivative of sine squared, can you say cosine squared?
Sine squared means all of sine squared. So your first thing is bring the power down, lower the power by 1, and then chain rule. So it would be 2 cosine x times negative sine x. Or you could write it as cosine times cosine and do product rule.
So why did he bring the 2 down in this?
Like that? No? Anything back there? You need to do a pencil or put all your work on a separate sheet. You're not gonna have space. I'm just telling you, it's not, you're not gonna be able to fit. Some questions take some space. This is what 18. Yeah, it's number 18, but it's
I don't
still
know chain
important.
efficiency numbers.
This one's 18.
So, on this one, why couldn't flat plane things be 4x times sine of 2x squared?
What, one more time?
So like, how I originally did it was like,
Oh, it used
If you bring the power down, lower the power by 1.
So it's like
That's not your
3 layers
inside,
instead
though.
of 2 for the chain rule. So you do this.
Your inside is not x squared
So you
yet.
bring it to the power
Your
down,
inside.
and the inside is the outside.
This is why with tree
And then
functions,
you do
sometimes you're gonna write
the
them like
one part, which
this.
is just the
oh,
side.
I see.
Oh, that's literally what I did.
Okay, yeah, okay.
What do you have?
2 sine of x squared times 2.
times 2?
Oh, that was just to do what I was trying to do the chain rule of, but that doesn't make any sense because you understand.
What was the original question?
The first thing was sine squared.
What was the original question?
The original question was sine squared, and then
So if we write it like this,
it was sine squared of x squared.
oh, you just split it. Like that?
Yeah.
Okay, then the first thing would be bring the power down, lower the power by 1, but the inside is all of this stuff. The derivative of sine something is cosine something. And now, this was the inside, so times another 2x. You have to use chain rule twice. But if you don't think of your trig function written like this, you're not gonna realize that all of that is your inside function. So you're not gonna get the correct first chain rule.
I'm thinking, what is the derivative of 5? It's just 0, but 0 times anything is 0, so the whole thing's 0.
asking if we should take power rule first and then
Take the
the
derivative
size.
Sometimes.
So the same question.
It's okay.
Wow, that's one. It has 2 steps of chain rule. One derivative. Bring the power down, lower the power by 1. Derivative of the inside because of chain rule, and then derivative of that guy's inside because of chain rule.
But it's still just one derivative. Man, this class knows how to make me feel dumb.
It defines something.
X squared times x squared.
The inside function originally is sine x squared. Its derivative is cosine x squared. So that's the first thing. And that has an inside of x squared, so his chain rule is 2x. Write this as cosine over sine times 1 over sine. Split it up. Okay, to make sure that we are all kind of at the same base here, is everybody okay with question 1? Do we need to work out question 1? Everybody got 5 times x squared plus 7 to the 4th times 2x on question 1? Okay, then that would be here. For number 2, did everybody end up with 5x over the square root of x squared plus 2? If not, I can work it out. Everybody got that for number 2?
Mm-hmm.
Okay. Number 3 is down here. And you should have ended up with cosine of x squared plus 7 times a 2x. Anybody need to see number 3 worked out? Okay, number 4. Number 4, I ended up with 3 square root of x squared plus 7. Everybody okay with that one?
Where did you get that?
Okay, well tell me what you think the first step is.
Well, bring down the 3 halves.
Okay,
Power rule.
and lower the power by 1.
Alright.
Okay, what else?
Then you use the chain rule on the x squared plus 7 to the 1/2.
Okay, what's the derivative of x squared? Now, just the inside part, so just the x squared plus 7.
2x.
Okay, so the chain rule is 2x, good. So, times 2 divided by 2 can cancel. To the 1/2 is the same as square root. That's done.
For some reason I brought that 1/2 down. Like tried to get the derivative of the equation to 1/2.
Well, it sounds like you're trying to do derivative more than once then. You bring the power down, lower the power by 1, all of this stays the same, times the derivative of the inside.
Okay, that makes sense now.
Okay, just one or two more real quick until I can figure out what's the first one really holding y'all back. Number 5 was back top left. And on this one, I ended up with a 4x sine of x squared cosine of x squared. Does anyone need to see where that one came from? Everybody got to that one already?
Yeah.
Okay. Number 6 was the first one that I had to be a little bit more careful on.
I'm still confused on 6.
Me too.
Wait, didn't we do the whole thing?
No, you stopped at. Wait, is that just the answer?
I mean, this is the derivative, but it doesn't look like any of the answers yet, so we
Yeah.
need to simplify it. Okay, so you want help simplifying it?
Yeah.
Well, I see that over here, I've got a times 2 divided by 2, so those are going to reduce out. I'm going to distribute this 2 back in, so I've got 2 times this, and 2 times an x squared over this. You okay with that?
Wait. Where did you get 2x squared?
I'm distributing this 2 back. 2 times this gives me this. 2 times this.
Oh, that,
These canceled,
okay.
so x times the 2 gave me 2x squared. So you're okay with that?
Yeah.
Okay, and then I started looking at my answer choices, and the one that looked the most similar had a common denominator of this, which made me think I needed to add my fractions together. So the right fraction already has the common denominator, so I'm going to leave him alone. But the left fraction needs the top and the bottom multiplied by this common denominator. Okay, so I get 2 times, what's the square root of x squared plus 7 times the square root of x squared plus 7? Now if you distribute this 2, you've got 2x squareds plus 2x squareds, which gives you 4x squareds. 2 times 7, which gives you 14. And now it's over the common denominator. So the only reason I added those fractions together with the common denominator is because my answer didn't match up with any of them. And I saw that's what they may have tried to do.
Which is more, and then you add it in there. Okay, so you're still taking the x in the first part.
Right, so it was the unknown to
I don't know if I can live in this house.
You did the product rule.
Oh, we did product rule first.
And so he got x to the.
I was just trying to do straight check.
I don't know. I can't tell if you're on the right track. What I meant by this is it's sine over cosine squared. Is that what the problem was? I'm saying that this is like cosine over sine times 1 over sine. These are saying the same thing. This is cotangent This is cohesion. Now you can do product. Okay, you guys have 1 to 2 things to do for homework between now and Monday. You need to finish up the chain rule circuit. Of course, some of those are going to be harder than others, but chain rule is super important. And maybe start looking over your test review. Your test falls next Wednesday, so if you feel fairly prepared, you might wait till next week. But if you know there's a handful of things you're not ready on yet, you might start looking at those and moving that way this weekend.